Imagine you're sitting in a candlelit room with a single open book in front of you. The pages are filled with arcane symbols and complex equations. Suddenly, your eyes land on one particular formula. It's unlike anything you've ever seen before, yet there's something about it that feels deeply familiar. As you trace the elegant curve of the equal sign, you feel a shiver down your spine. This isn't just a math equation. It's a gateway to another realm, a place where numbers dance and formulas tell stories of the universe itself. You've just stepped into the world of facts matter. Welcome back to the channel. Today, we're re-diving into the fascinating world of mathematics to uncover one of the most intriguing formulas ever discovered by man. Get ready to have your mind blown as we explore the secrets hidden within. So without further ado, let's dive right in. In the 18th century, there lived a brilliant mathematician by the name of Leonhard Euler. He was a true prodigy whose mind could grasp the most complex mathematical concepts with ease. One day, while working on a particularly challenging problem, Euler stumbled upon a formula that would change the course of mathematical history forever. It was a formula that connected seemingly disparate areas of mathematics such as exponential growth, trigonometry, and complex numbers. But what made this formula so remarkable was its simplicity and elegance. In just 3 short symbols, Euler had managed to capture the essence of some of mathematics' most fundamental principles. So what exactly is Euler's formula? In essence, it is a bridge between 2 different types of mathematical functions, exponential functions and trigonometric functions. On the one hand, we have exponential functions like e to the power of x, which describe phenomena that grow or decay over time, such as population growth or radioactive decay. On the other hand, we have trigonometric functions like sine, x, and cosine, x, which describe periodic phenomena such as waves or oscillations. Euler's formula shows us that these 2 types of functions are actually more closely related than we might think. By using a complex number in the exponent, we can express the exponential function in terms of trigonometric functions. And vice versa, we can express trigonometric functions as exponential functions. But Euler's discovery didn't stop there. He went on to make an even more remarkable observation. When he set the angle inside the formula equal to pi, he arrived at an equation that has become known as Euler's identity. It is one of the most famous equations in all of mathematics and has been called the crown jewel of mathematical formulas. Let's take a closer look at this incredible equation and see why it is so remarkable. Euler's identity is a special case of Euler's formula where x equals pi. When we plug this value into the formula, we get the following equation: e caret I plus 1 is equal to 0. At first glance, this may not look like much, but when we break it down, we realize that it is an incredibly powerful equation. Each of the symbols in the equation represents one of mathematics' most fundamental constants. What makes Euler's identity so remarkable is that it is able to unite these 5 fundamental constants in a single equation. It is a testament to the power and beauty of mathematics that we are able to express such a complex relationship in such a simple way. But Euler's identity is more than just a pretty equation. It has deep implications for our understanding of the universe. For example, it is used in fields such as quantum mechanics and signal processing to model and analyze complex phenomena. It is also used in engineering to design and build systems that exhibit oscillatory or wave-like behavior. To truly appreciate the significance of Euler's identity, we must first understand the historical context in which it was discovered. Before Euler's time, mathematicians had been struggling to understand the relationship between complex numbers and trigonometry. Complex numbers had been used for centuries to solve equations that could not be solved using real numbers alone. However, they were still largely seen as a mathematical curiosity and their full potential was not yet realized. Similarly, trigonometry had been developed to study the properties of triangles and was widely used in fields such as navigation and astronomy. However, it was not until Euler came along that mathematicians began to see the connections between these 2 areas of mathematics. Euler's discovery of his formula and identity was a watershed moment in the history of mathematics. It opened up new ways of thinking about complex numbers and trigonometry and laid the foundation for many important developments in the field. Unfortunately, Euler was not able to fully explore the implications of his discovery due to the outbreak of the 7 Years' War, which led to the Swiss mathematician being imprisoned in his own country. Despite this setback, Euler's work did not go unrecognized. His contemporaries, including the great physicist Albert Einstein, recognized the significance of his discovery and praised him for his brilliant insights. Today, Euler's identity is celebrated as one of the most beautiful and important equations in all of mathematics. It is a reminder of the power and elegance of the mathematical language and the profound insights that can be gained through the study of mathematics. If you're interested in learning more about this incredible formula and the brilliant mathematician who discovered it, I encourage you to check out the additional resources provided. You'll find fascinating insights and applications of Euler's identity that you won't learn anywhere else. Do NT miss out on this opportunity to deepen your understanding of one of the most remarkable equations in history? We hope you enjoyed learning about Euler's identity, one of the most fascinating formulas in mathematics. We want to thank our amazing viewers for your continued support and encouragement. Your passion for knowledge and exploration of the unknown inspires us to create more engaging and educational content. If you're eager to keep exploring the wonders of mathematics and science, we invite you to join our community. As always, stay curious, keep asking questions, and never stop seeking answers. The world of knowledge is vast, and we're thrilled to have you along on this journey of discovery. Thank you for watching, and we look forward to seeing you in the next video. Now it's time to put your knowledge to the test. Can you solve the following problems related to Euler's identity? If you think you know the answers, leave them in the comment section below, and do forget to subscribe for more exciting videos like this one.